Okay, in this video we are going to apply the wave equation. So we need to first discover what is the wave equation. And before we do that, we need to talk about these words: speed, frequency, and wavelength. So let's open our simulation here. So let's start off by creating the wave and talking about a definition we already know. So as time goes along, these beads will move up and down, so we know that it's a transverse wave. And wavelength, so this is a term, wavelength. Wavelength is the distance it takes for one complete cycle to occur. So the symbol looks like this. The units, well, it's a distance, so in this case it's going to be about 3 centimeters. So the units for that are going to be centimeters or meters. The definition is the length of one full cycle. So again, it's this distance right here. Now we can also talk about the time that it took for that to occur. So in this case, the time that it took for that to occur is measured in seconds. The time for one full cycle, and we give that the name, we call it period. So the period is the time it takes for one full rotation, and it's given the letter capital T. So there's one more definition. So right now it's about 0.5 seconds. Let's keep playing this. So waves moving along, still going. Okay. Something happens, we're going to get to 1 second. So there's a word that's used in physics called frequency. And it's given symbol F. And frequency is how many cycles occur in 1 second. So we've played this for 1 second, and let's try to count how many full cycles have occurred. So from here all the way around, that's 1 full cycle. And then from here all the way around, and that's 2 full cycles. So what this is saying is that there's been 2 full wavelengths. One wavelength is 3 centimeters, and about 6 is the second wavelength. So 2 full cycles have occurred in that 1 second of time. Now the symbol, I should say the unit, is hertz. So how do we relate period and frequency? These have some sort of relation between them. One is the time for 1 full cycle, and the other one is how many cycles occur in 1 second. So in this case, frequency, we found it was 2 hertz, so there was 2 full cycles in that 1 second of time. But we can relate these two with one another through the following. Period and frequency are what's called inverses of one another. So let's see here. Period was how many seconds for 1 cycle. And period, if I'm looking at this equation, 1 all over, period was how many cycles per second. So if you see our units, if I take the inverse of this, switch the bottom and the top, and I get back to seconds per cycle. So the units work out for this equation. Now that we have our definitions of wavelength, period, and frequency, let's go ahead and figure out what the wave equation is. So let's think back to last year when we learned about acceleration. And if there's no acceleration, another way of saying this is constant speed or constant velocity. Then we know that speed is just your distance all over your time. And again, this is for when there's no acceleration. So let's go back, restart this, play it for one full rotation, one full cycle. Good. One full cycle. So if I'm looking at my equation for constant speed, speed is distance over time, I could say if I measure that distance to be one full wavelength, so instead of x, I'm going to use the symbol that we used before for wavelength. Speed, we can say, is wavelength, which is measured in meters or centimeters, all over the time that it took for one complete rotation to occur, or our period, the time for one full cycle to occur. So right now I've created an equation that can relate speed, wavelength, and period. Now if I wanted an equation that could relate speed, wavelength, and frequency, let's use our relation between period and frequency, and I can say frequency is 1 all over the period. You can write it either way. And I can rewrite this line this way. Might be easier to see. So speed is just your wavelength times, well, if I sub in frequency for 1 over time, we see that speed is just the wavelength times the frequency. So this is your wave equation. You can write it either way with frequency, or you can write it with the period over here. But it's saying the same thing. So if we look at an example problem, what is the wavelength of a sound wave with a frequency of 50 Hertz? Okay, so my frequency is 50 Hertz. The speed of sound is 342 meters per second. So if I apply the wave equation, I could say speed is just, let's review, the wavelength times your frequency. And in this case, we just plug in our numbers, 342 meters per second. My wavelength is what we're trying to find, and my frequency is 50 Hertz. So we get our wavelength all by itself. Divide both sides by 50. And what we're left with is 6.8 meters, or 6.84 meters. So hopefully at the end of this video you can now, well, you understand what these terms are, but you can also apply that wave equation, which relates speed, frequency, and wavelength.